um, Good evening, guys. Can you hear me? And how's the sound quality?
Good evening. We can hear you, and sound quality is good.
Okay, great. All right. So I suppose we can start going through our things, and probably as you have seen, I submitted well, not really submitted. I just defined you another home task. So you will need to build a calculator, which is a super simple thing. Maybe I have to share the screen at this moment. Yeah, let it be shared. So in assignments you can find out GUI app for calculator. Literally, what you have to do, you have to do not only those visuals, but you even have to make all functionalities. And surely about the keyboard, well, you say have something maybe not really ordinary layout, but in your case you can just choose whatever layout you would like to have. There is no difference, and you will have to make those four operations: multiplication, division, minus, plus. Literally, nothing super complicated. Well, that will be a solution I expect you'll make. All right. Well, let's maybe take a look once again how all of these elements can be created. So I will open the previous presentation. So what did we have? We had the main window, and we created using the component Tkinter. So what literally we make? We make the object itself. And here I use a variable top, but actually there's no difference which variable name you're using. Okay, so we create the object, and by using the main loop, we literally run that object. Well, we are running actually the same function as you are running, for example, in C++ as Windows process that waits for user comments. I'm not sure how advanced your C++ knowledge is, but it is how it works. So here, literally, we have the same principle. The only thing we don't really make anything inside this function, but in C++ we must do that. Okay, so we can have some buttons. So we can use button for making the button. We can even have such fancy model window by using a message box object, while using a show info function. And once again, we specify header text, which is here. We specify the body text, which is here. And actually, guys, we can even modify the icon if you like. Well, I would say you can just take a look on some menus, all of those parameters we can have, because here we have only two parameters, but actually there is a bunch of those varieties, Okay, we can have the drawing, so we can have the canvas for drawing something on it. Literally, we can have some arcs, we can have the image, we can have some lines, polygons, and lots of other visuals drawn on the canvas. Okay, well, we can have some check buttons. When we create a software, it's not possible to work with these elements because you're about to choose something. Maybe when you save information about, let's suppose, the warehouse, so you have to check some possibilities in your application by a check button or by radio buttons and so on and so on. And once again, the implementation of them is quite simple. Like we're using the check button, and we just set up several parameters. We're using for specifying, the space which is taken by this element. Maybe some offsets, maybe some text inside should be specified, as well as a variable which will receive the status of your checkbox. The entry, well, entry was just a text which you will definitely need to use in the calculator. And literally, how can we specify that? Well, we can specify it in a such way when we even say what text will be saved inside that from the very beginning. Oh no, it was the label. No, but actually we can in a similar manner specify the text for the entry as well. Well, we could make a set of elements. For example, we can merge several buttons into one object, and we can just pull that on the top side of the window or in whatever other. And as you know, well, each side and each corner of your window has its own name. So you can, for example, Google on those names, and you will find out some abbreviations. Literally, I mean the small names of those sides. Like, okay, we can have left, bottom, right, top, but in the same time, the corners have their names. Mostly, if I'm not mistaken, those are formed by two letters. Okay, the label, and well, it's just a text which can be just written on your form, and you cannot change that, but it helps us just to understand what information is shown in the form. And through this text, we can just give some additional information to the user. The list box. Well, this element is used for just giving you a list of elements. And you potentially can select whatever element you like from the list, and after each clicking on this element, you can even run a function that basically says, well, which element's index is used. Okay, here we have just a small code that shows us how we can fill that object with some values, which is, I would say, super easy. Next, we can have some menu, which actually one of my favorite elements in the Python, in the Python's GUI using Tkinter element. So we can just hide under one button a lot of those selections, For example, we can have some checkboxes, but we are not only limited with the checkboxes. You can take a look what do we have under this menu, which functions we have. And actually, guys, Tkinter it's just a folder on your computer, literally, which contains a lot of elements, a lot of files, and each of those files literally is the Python file, which contains the class definition. That's it. So if you like, you can search for such folder on your computer, where you have the Python installation, and you will find out how it's structured inside installation. I mean, in the file system. Okay, so here we have few check buttons. They have some text. We even assigned a variable, actually two variables to store this information. Next, it's been just compiled, and that's it. So the formula is being run. So nothing super different from everything else. Well, the message is just a kind of big label, so just a text which can have additional options, mostly being multi-line, but once again, it works in a similar manner as literally our that label element works. Okay, here we have the text variable defined, but actually, in a similar manner, we can try to work even with the label. The radio button, well, one of mostly used things, because sometimes you have to make a switch between several options, and when you have some window that shows you a question, maybe would you like, I have no idea, to pick some objects. Okay, it's harder to imagine some certain question we could have answers for. Maybe would you really like to erase the element from a table? So you just specify yes or no. Okay, here we have a small code how to create those radio buttons, and well, what was super interesting about them? The super interesting thing that they can be specified. You can see in the same manner as all other elements. The only thing that for the variable we set up the same. Well, what it means? Well, if you would make a close look, you will see that each of those radio buttons have different values. So one has 1, another 2, another 3, right? So it means that every time we just we switch between them, we give to a variable called var, and here you can see that it's been initialized from the Tkinter side. So each time we give one of those values, 1, 2, or 3. And we can even print out a text on the label, which is doable quite easy. Okay, another was the scale. About the scale, it's it's kind of normal element. We can use them. From my personal experience, I can say that I try not to use these elements, but if you like, you can definitely use them. Literally by just scrolling that up down, you can select the value, and that value just can be used. Well, in a way, you need that. The scroll bar, maybe one of not really interesting elements, but scroll bars in the Python can be merged with another elements, and that makes that element one of most interesting elements. So how that happens? Let's see. Yeah, and if I'm not mistaken, we didn't take a look exactly on this element. So literally here what do we have? We have the main window itself. Well, it has variable root right now, not the top like in some previous examples. We have a scroll bar, which is placeable in the root. And as you know, guys, the scroll bar pretty regularly is being just placed on the right side. So if we would like to have the same dislocation of that, so we are not making any other configurations, but we can even set up that just directly. What's the interesting? The interesting thing that the scroll bar will be working for the vertical positioning. Okay, well, we set that up. Okay, next line, we make the list box. And here we have the element to which we assign that. So the list box will be inside our window. And entire element's vertical position will be based on the scroll bar's position. So in other words, we can just scroll the list. Well, it's not working so easy as I described, but the result which we can see literally looks like as we are scrolling that. What happens next? Well, next we can just fill the list box with some elements. For example, we will have some 100 elements starting from a 0. So the range, if you don't remember, makes the array. And since we have 4 in, we literally go through all of those elements we have in this range. If I'm not mistaken, here we'll have elements from a 0 to 99. In some of Python versions, the last element of the range somehow was not implemented. I don't really remember, was it related to just range in one argument or two arguments? But you can find out that just trying to make those arrays. Okay, and as you can see, we just add the element. Yeah, and what's next? Next, we just compile our object. We say it will be binned to the left side, and it will have, well, if I'm not mistaken, it was related to text alignment. Okay, and then what do we have? Well, we configure our scroll bar. So right now the scroll bar position will be changed once we change at least top element index. So if we put a cursor inside and we click on the arrow on the bottom and you don't have a zero element on the top, so you will see that your scroll bar will be scrolled in automatical way. We can take a look if that's working, so and how that's working. So let's copy this, and yeah, so let's copy that, and let's open the script. Maybe I will use this bin.py. No big difference. What I modify here. Okay, so this line should be just one line. Here I will have just some space between the left side and the comment itself, because this operation goes inside this instructions block. Okay, next I'm packing that. I'm configuring the scroll bar. And I just run the form. Okay, so this one is saved, and I need to go to this folder where I have this file using SIMD, using the command window. Oh, what happens? Okay, looks like I didn't copy the folder's name, the folder's path. Next, we are going for the Python and then b.py. Okay, so we can see the scroll bar, and we can literally go to elements. So by the configuration, we remember that there are two actions. When we scroll the scroll bar, well, the vertical position of the list element should be changed. In the same time, when we go through the elements, then the vertical position, well, the top element literally says what will be the position of the scroll bar. It's not defined, using full code. So the real implementation is not really hidden from us, but right now we are not just seeing that. So let's see. So I'm scrolling the scroll bar, and as you can see, once I do that, the list is being scrolled as well. Next line. Well, and this happens by which code? So it happens by this code. So each so-called visual elements update, what happens? So literally the scroll bar's value is being used for vertical position of elements inside the list box. So it goes by these codes. Okay, so what happens using these codes? In these codes, a position of scroll bar will be changed based on the vertical position of the list. What it means? So it means if I will go on the bottom using in this elements list using, for example, the arrow on the bottom, what will happen? So once I do that, you can see that scroll bar changes that position. So yeah, well, that's the idea. Well, I suppose this one would be clear for you. Okay, the other one, so text. Well, we can make the text area where we can just write some text and we can even apply coloring. Well, I can say that here the color and all of those styles are applicable in a bit, tricky way. So maybe we will not waste time on this. But you have to know that literally the text area can be just created. Okay, well, sometimes we have to use several windows in the application. So how we can do that? Well, we can make the main form, and we can have additional one. So in this case, we are running this additional form as literally the main one. Well, which one to run by that? Well, it's a good question. And the main form will be which will be run by a main loop, actually. Which means that if you are closing a form which is not the main one, then the main form will still be active. If you're closing the main form, it means that you're closing the application. So that's the paradigm, and this paradigm actually works in totally all programming languages. So it's not something specific, in other words. Okay, the next one, Spinbox. So the Spinbox is just numerical values, so-called setter. So you can just click on those buttons up and down, and you will change the value. Another one, the panel window. Well, the panel window works, I would say, in a similar manner as those buttons, which we previously grouped. So idea here is the same. So you can just have panels, and guys, you can just put some element on the panel as well. And in a similar manner as previously for the form, the form has literally 9 different positions, being it angles, no, corners, then sides, and can be centered. So the same works for every panel. But once again, that's really up to you if you use on this. But I would recommend to use that. Okay, well, label frame. Maybe one of elements I really like in the Python's GUI, because you can literally group your elements, and it doesn't matter what's inside those elements. For example, a lot of programming languages allows us to group only a few types of elements, which mostly the checkbox and the radio box. In this case, we have we can pull inside the whatever we like. So, for example, we can have where do we have something? Yes, the label that goes in the labels frame. And labels frame has the text. Well, I think it's quite obvious. Okay, so at least these are those basic elements you can start using in your, let's say, daily tries to make something in the Python. Okay, well, I suppose that there should not be a problem related to a calculator home task. Okay, I will check the chat if something is written in the chat. Okay, nothing is written. That's awesome. And right now, I would like to take a look with you guys on maybe a bit specific kind of subject, but anyways, it's another usage of the Python, and we can literally take a look how we can use that, right? Because it's not overcomplicated, to write some codes, assigning a text to a variable. Well, even a lot of other things are um, far from being complicated. Well, really, really complicated. But their combination, gives us some solutions we use daily, for example. Okay, let's take a look on such things as Python and stenography. Okay, so I will open this presentation here using the screen sharing. And let's take a look. Okay, maybe some of you already know what stenography is. Not stenography, but steganography. What is it? Maybe you already use that sometimes. Okay, I can wait for some 10 seconds. Maybe there will be some text in the chat from your side. Sorry, I didn't hear you. Your voice was super breaking.
No, never used that before.
Okay, awesome. So let's maybe take a look. Evgeny wrote that hiding some codes and pictures. Kind of, but I would say hiding some text, some information. Let's better call it information. Because what we can literally hide, in the code. So in pictures and in audio files, well, we can hide some information, we can hide some codes. And what hackers do, they hide the code in pictures on a programmatical level, actually, and those codes are being just executed. So our story is not about this case, but also this case is not complicated. Actually, it's really not complicated because actually the cybersecurity thing is the thing which I'm working with, by the way. So it's really not complicated to hide any codes in some audio and video elements. Okay, but it's not how to say our story. So our story is about how is it possible to hide some information in a picture. For example, you have some picture over the internet, and you're about to maybe share that picture with some friends, and if your friends know the way how to take that information out, if they, in other words, know the template, then they can take a look. They can take your picture and find out some hidden text inside. I suppose that sounds at least interesting, at least somehow interesting. So let's see how that's implementable. So Python and steganography. Okay, so literally, I already told you the idea behind that. Let's maybe think about how exactly the information can be stored, Okay, well, what's the picture? Let's remember what's the picture. The picture actually is the bunch of pixels from a user perspective. From a programmer's perspective, it's not really so. There are a lot of additional data. And literally, there are image and actually audio formats as well, with so-called lossy compression. About data compression and lossy and lossless compressions, we'll take a look on them. It will definitely happen because actually I have already those materials prepared for you, but we'll take a look on them. Well, maybe next time or after the next time. Let's say. So literally, a lot of data is saved in the file, which is graphical file. So We literally can write some bytes inside the picture, but let's think about how. And what does it mean to write a byte in the picture? Well, if we will try to remember what was the picture, a picture is just a bunch of pixels. Well, and we call them, by the way, pixels. But what's the pixel exactly is? So the pixel is a tuple of three elements. So and we call them RGB, which goes for all digital only. For digital only format. There are even a lot of others mm, like CMYK, which goes for the printing, and a lot of others are available. But we are talking mostly about the digital only format. So RGB, which means we have the red component, green component, blue component. And as you know, guys, their combinations gives us a lot of colors we can see. For example, how it happens that on the screen we see the yellow color? Well, it's just a trick for our mind, actually, because a combination of the red and green channel, literally the light, right, gives us an illusion of yellow color, because actually all of those colors are just, well, they can be represented as so-called radio waves. Okay, but the story is not about this, and not about the physical aspects. So in IT, we can set up each component's value of red, green, and blue channel, and the value varies between a 0 and 255. So overall, we have 256 variations, which is the same as one byte can give us amount of its value of variations. So we can say that each pixel is the portion of 3 bytes. And if we try to keep this in mind, so we can right now understand why there's so huge, or let's say big cords for well, in between of the monitor and the computer. Well, because each some 5 or 10 um, um, microseconds, I suppose, there should be a huge information flow between the computer and the monitor. So that's why those cords are so big, not comparable to some other cords, like like with the cord which is used for charging the mobile phone, for example. Okay, it's known for us that the value of the channel of the pixel has the size of 1 byte. Okay, and where else do we can we find out the text, for example, where each symbol is well, each symbol takes 1 byte size. Well, it's so-called 8-bit characters, which literally is the same as ASCII tables elements. And by the way, it's really the same. For the case when we have elements from a 0 till 250. So if you don't remember what the ASCII table was, I will show you. So here we have the ASCII table. Let's open that. Okay, so literally here we have 7-bit ASCII table, and we have an extension of that gives us more varieties till 8 bits symbols. So from a symbol with the number 0 till the symbol with the number 255. So literally, the value of the pixels channel can be just, assumed to be the value, the ASCII table's value for a symbol. That's the overall idea, guys. So let's see how that works. So Nextly, the thing is that we have to pick a picture which basically has some combinations of colors, or some certain color of those of the channel colors as the main one, as the color which value can vary on the picture, and where we have a lot of them. So, for example, here we have a really nice picture with the cat, with the cute cat, and if we would try to think about, well, which channel here is mostly used and has a really color varieties on this picture, well, we see that mostly here we have some half tones of the red color, and we have something like a yellow or yellowy brown colors, right? So for the red color, it's clear we have the red channel, and for yellow colors and brown colors, well, literally for the yellow color we have red and green channels used. So we can say, well, the red channel of the pixel is mostly used on this image. And by the way, since the picture is taken, at the moment when sun was shining on the cat, so we can say, well, there is no any prediction of what should be the value of the red channel of the pixels, because they can be whatever, literally. There are super huge amount of factors that would affect that. So, what could be the steps for writing the information inside? So, first of all, we will need to have the library pillow. Well, actually, I already showed you here. I pulled here the command for the CMD to install the library pillow, so you can try to use that. I hope it will work on every computer. Next, we have to literally open the image. We have to have access to the image size. We have to load our pixels, and we have to write somehow an information about modified pixels in the file, So, for example, your friends could have a list of pixels from which they have to take out information, because without that it wouldn't be obvious from which pixels to do that. So next, you have to have the text. So by the input, we can ask out from the user a text. Actually, the user will have to must write the text, because it's what assigned by the application. And here you see we have a special construction. We have the array in which we take ASCII codes from some elements, and that element comes from this for in construction, where we are going through the text, which is defined using this input command. So that's the story about this text, about this code. And then what do? We use the randomizer to receive some random XY position. Next, we have access to pixels. We have access to that certain randomized pixels value, and we take only few components from that. So literally from the index 1 till index 3, excluding the index 3. So it means index 1 and index 2, but index 0, which comes for the red channel, is not taken, and that those values are saved in the green and blue variables. And then we draw the pixel with three components: green, blue, that comes from a symbol, and the red channel or a red component literally comes from our element, because this LM will take the ORT LM from the array. So we literally pull our text inside the red channel of random pixels, and then what we do? We just saved some somehow the information about this pixel. We save the file, and we close the file with those pixel positions. So so it's not quite complicated. And in the end, what do we have? Well, we have the picture itself. And by the way, afterwards you can try to find out differences just visually. If there are some differences in colors, if you will find them out just visually. And in most of the cases, well, I would say in some 99.99% cases, you will not find any difference because firstly, it's not possible to compare, pixel by pixel using just eyes and just looking onto images. Well, at least in my case, it's not working. How is it possible to take out the information from a picture? So surely we have to have the path for the image. We have to have an access to pixels. Nextly, we have to have a file with those positions of pixels, of modified pixels. Nextly, we have to somehow split that in text. I mean, the file to the text. Nextly, we can use, for example, the regex to find out x and y components of elements, saved in the file, because actually we can save that in different ways. And what happens next? Well, nextly we just go through the array of those textual elements. Sorry, no. Here we go them through, and we literally add to the array the red channel of the pixel, which position is saved into this array keys. And by key, we just go through those elements in that array. Well, and that's it. So we have all of those literally ASCII codes of characters. And you see here we have the array. So we will have each element of the array is the character from the number, and where this number comes from. So it's each element of the iteration, where LM is the element of array A. And that's it. So that's the full story, guys. Let's maybe take a look how that works. So let's see. Let's take a look on files which are available for us, which I uploaded recently. Okay, let's download them, and I will go for pulling this folder here. Okay. Nextly, what do we have? Well, maybe we can erase this thing because it's the result of encoding, and we have encrypt text codes. Literally here we have the same thing which was mentioned previously. So we are opening the image, we are having access to pixels, we having the size of the image, we load those pixels into variable, we create the file for modified pixels positions, we ask a text from the user, we go through the text, and we receive the ASCII number from each symbol of the text. We generate the random pixel position. We take green and blue channels from that pixel. We save the pixel using the red channel, which is the ASCII number of the character, and that's it. So we save information about that particular pixel, and that's it. So afterwards, what we do? We save the image, and I recommend to use the PNG format because the PNG is a lossless format, so it doesn't lose information. When JPG and all derivatives from a JPG loses the information. So just keep this in mind. But we'll have a talk about this on one of next times. And then we close the text with text file with those positions of modified pixels. Okay, and that's it. So afterwards, we just run the function which we created right here. Okay, well, let's see how that works. So what I will be doing? Well, I will go to this folder just to run scripts from that. Okay, and I will go for the Python. What was the name of the file? Encrypt. Encrypt.py. Oh, okay. So I don't have the library on this computer. Okay. Okay, that's fine. So I will use pip install pillow. I hope it will work for me. Yeah. So it's loading. Okay, it will take okay, it will take some short time. It's a kind of small library. Let's wait until it will be installed. Okay, that's great. So so we have the pillow library, and now we can run our encrypt.py file again. Okay, so we're about to have the text. Okay, so I will maybe use text computer. Computer. Okay, so text is saved in the image. We receive the image itself, and as you can see, why those sizes are different because of extensions. Here we have JPG, which is the Lucy format, so it's a priori has some losses in the quality. It just happens 100% in cases, and PNG doesn't have this, but it takes more space. But anyways, this spacing is not comparable to BMP formats, which is non-compressed one. So, and we have these keys, and how these pixels are saved here? Well, they are saved in such a way. So you can see that we have COMP, COMPUTER. Yeah, so we literally have all of those positions, and the amount is the same as we had amount of symbols in our texts. Okay, so that's it. Let's maybe run another code and let's see how the decryption file looks like, how the decryption code looks like. So as you can see, that's the whole code. So once again, we use the Pillow library. We open the image, we load in pixels, or we're opening a file with modified pixels positions. We load that as lines. We use the regex to find out values in between of those texts in the file. Next, we go then through, and we use those XY positions to have an access to the pixel. And from a pixel, we take only the first, I would say the zero indexed component, which is the red one. And here we go through them all, having them in the variable elem. And from the elem, we receive the character. So the elem was the ASCII number of the character. And we have this array, and we join an array with the text, which gives you in the result the text. And that's it. So you will have the message received from the image. Okay, let's see how that works. Let's go for our CMD, and let's write Python decrypt. Okay, and let's see what we have. So we have computer, and this computer is the text which is received from the image. And literally that's the full process. So there's nothing super I would say complicated or something maybe from another comments. So literally basic operations, in other words, but their combination gives us this interesting result. Okay, well, how is it possible maybe to extend all this? Because the solution is fine, it's really looks awesome, but the only thing, well, how is it possible to modify it, to make it even better? And as you know, there is the GUI for this. So I have one file, and I will maybe open that file for you guys. So okay, here I have that called form. Okay, I will download that. Okay, how to download that? Oh yes, this way. Okay, and what do we have here? Let's take a look. So so we have literally a combination between fonts, between frames, which we already have seen about the framing buttons, as you remember when we had bunch of the buttons. And we can use some functions which can be assigned to buttons. So, and we can literally do everything the same, literally, for encoding, decoding text. And in addition, we can even rescale the image just in order to show that image in the canvas. So here we have decoding function, and we have few buttons here like encode, decode, and the canvas, on which it's possible to draw the image. Let's see how that works. So I will run this file. I will maybe just rename that as the form in my particular case, and I will go for Python form.py. Okay, so what do we have here? Well, we have encode decode, and I will go only for a decoding. So as you can see, guys, the app showed me the text we just encoded into the picture. So this works pretty great. And in the encode, I already wrote some code for pulling inside the image. And as you can see, we can even show some image on the form, on the canvas. The only thing that here that image should be, well, how to say, be sticked in the canvas, because once I put a cursor on that, the canvas will be just refreshed. And since it has its own background color, so it will be refreshed by this blue background color. Well, that's the idea here. So what I think you can guys even do similar things on your own. I suppose this. Well, that's the idea. Okay, well, I see by the time that we have some around 5 minutes. Okay, so I suppose there could be time for Q&A. So guys, most of the shown clear. Maybe you have some questions, so don't be shy to ask them. Because so far I didn't receive any single question in the Moodle from your side. I really hope it means everything's clear and fine. But anyways, I just reminding you about this opportunity to write the questions. Okay, guys. So, is everything clear for you?
Yes, for me.
Okay, maybe you need some hints related to a calculator home task.
Maybe about the shades around the buttons.
Oh, all right. Let's see. So, what did we have? Oh, hey. Here we will have well, if I'm not mistaken, the newest Python will have several nice looking options for this, because here we have some, old style those shapes, but but literally it's doable the same as we have here as the line around the entry. Okay, so line around the entry. Let's start with that. So where did we have it? We had it in GUI presentation. Okay, it was quite obviously written here. Yeah. So as you can see, it's the border. Actually here we have these pixels, the border width literally, and you can try to. Well, why I say try? The most of the elements, the visual elements in Kinter has the same parameters for some reactions like on click, on comment, and others. So in a similar manner, you can try to use this VD for a button. Okay, let's maybe take one and let's maybe put a modification in the form.py. Okay, where did they have them? Oh, okay. Like VD equal to 5. I will save that. And I will run that. Yeah, so as you can see, guys, right now, what happened? Well, the shape around the button became bigger, right? And we can see this in comparison between the button encode and button decode, right? Sure, we can have even bigger value, but that's I would say up to you.
Thank you.
Okay, maybe some other questions. Okay, looks like no questions. I really hope that it means that everything was clear for you. Okay.
Google will help for us.
Okay, but you know, guys, since I'm here, you can always ask a question, right? I understand that Google will help you, but okay, I would say that's up to you. The only thing I wouldn't really like to hear in the end, well, I don't really remember this, I don't really remember that. But okay, in the end, you will have the project definition, which we will definitely talk about. Okay, what do we have? So Evgeny sent some Python basics. Okay, is that a book or something? Okay, what's this one? Oh, okay. I will definitely save this thing on my computer. Maybe if there is the GitHub for everything, I will just download that. Because I form a lot of these libraries about things. Okay. All right, guys. So take your time, please. Try to make that calculator, as well as if you didn't make the first assignment. So please try to finalize that. Because, you know, as faster you will make things, as less things you will have to make, you know. All right, guys. So have a nice evening and see you next time. Bye-bye, guys.
Have a nice evening too. Bye bye.
Bye.
Thank you. Bye.